Hey guys, so this is the last two examples that I told you that I will record. So hopefully you watch this and you understand this because somewhat similar questions to these may appear on the test. It's kind of a traditional, typical type of question. So if you take a look at this example, it basically is the same method as before, but remember that we're dealing with a quadratic functions here. So obviously the equation related to that is quadratic equation, and the thing that you have to remember of the quadratic equations form is that the factored form a and the x minus r and the x minus s. So the first point that you have to find, or first couple of points that you have to find, is the x-intercept. So in this case, the x-intercepts are at -1 and then 1, correct? So it is -1 and 1. Now for the second point that we have to find is the any point. To be honest, any point on your graph. As long as it is definitive point, as long as it is lying on the corner of each square, that's fine. So for example, do not choose any point like this. This is bad. Okay, this is a bad point. That's because we are not sure whether that is a 1.5 or 1.2. We're not sure, right? So the best point in this case may be the y-intercept, but that's because it is actually lying at the corner. So this can be our second point. So in this case, I will choose y-intercept as our second point. In this case, it will be a -2. Sorry, 0 comma -2. So the method itself is pretty much the same. Sub the numbers that we have into the equation and then try to solve for the a. Once you solve for the a, then substitute the a back into the equation and we are done. So now the -1 and +1, these are the x-intercepts. So obviously when it goes inside of the brackets, it becomes the opposite sign, okay? And then now the long way of doing it is basically f at x equals a, now x minus -1, which is this, and then x minus 1. Now this was the first x-intercept, this was the second x-intercept. So r and s basically means the x-intercept, but because of the negative sign right in front of each, it changes the signs to the opposite. So that's why when you substitute, or when you put the x-intercepts inside of the brackets in the equation, what happens is that it changes the sign to the opposite, like these. So the -1 becomes +1, and then +1 becomes -1. Then we substitute the second point, which is in this case 0 comma -2. Obviously 0 is the x value, but the -2 is the y value. Then you will start puzzling, where is y in the equation? Well, think of this way. Before you were introduced to the f at x, you've been using y all the time. So f at x actually can be replaced by y. So that means it is -2 is the y, or f at x, then a 0 plus 1, and then 0 minus 1. So then this becomes -1, right? Or in a longer way, it's 1 times -1, but that gives me a -1. So negative a is -2. This means that a is +2. So final answer then becomes f at x equals 2, and then x plus 1, and the x minus 1. And that's pretty much it. So when you're given a graph, it's pretty much the same. Just find the x-intercepts as well as just a random point. Okay. Now, the next question is a word problem. You may see this in your homework question as well. So, the example for this is Mr. O throws a football to his friend whose height is about 2 meters. He's 30 meters away from Mr. O. The ball nearly misses top of the friend's head and landed at 40-meter mark from Mr. O. Now, what is the equation that can be represented by this trajectory of the football? So, obviously, when he throws, so when you're dealing with a word problem, the first thing is try to draw the situation out. So here's Mr. O, here's his friend with a hat, let's say, and he throws the ball. And if it nearly misses the hat and lands here, if you kind of see it, it kind of depicts that it is a quadratic curve, right? So one thing that we can do is we can simply find the x-intercepts, which are the landing point and one of the points, which can be represented by his height. Now, in this case, I will assume that to make it simpler, I will assume that I am a midget. I literally have almost no height whatsoever, so the drawing actually becomes this way, where his head is right there in the ground. Okay, so this is the 30-meter mark, and this is the 40-meter mark where it landed, and this is the 0 meter where the ball is thrown. Okay, so the reason why we set it this way is because if I set me up here and give my height, it's going to make the question a little more complicated. That means that you may not be able to do it with the knowledge that you learned in this course. So that's why we're just going to make it simpler. Now then in this case, obviously we have quadratic. So we set it as, I'll just put it as f at x again, equals a x minus r and x minus s. So the landing point of the ball is the x-intercept as well as the throwing point, assuming that it was thrown from the ground. That will give me the x-intercepts of 0 and 40. Now, the other point that we should be able to find is where the friend is standing. So the friend is standing at 30-meter mark. So another point. So he's standing at 30-meter mark, but his height is around 2 meters, and ball nearly touched it. So we can say the point on this trajectory right here, we can say that is 30, 2, right? Because the height in this case represents the y value, and the 30 represents the horizontal value, which is the x value. Then rest becomes the same. So it becomes 2 equals, I'm just going to put everything at once, a, then instead of x minus, I'll just put 30 and then minus 0, and then 30 minus 40. So I put these 2 points at once, okay? So then this becomes a and then 30 and then negative 10. So it will be negative 300a equals 2. So this gives me that a is negative 2 over 300, which is negative 1 over 150. And then we're pretty much done. Now, then the equation becomes f at x equals negative 1 over 150, x minus 0, x minus 40. However, we can simplify x minus 0, so x minus 0 actually becomes just x itself. Therefore, this is the equation of this trajectory. Okay? Again, the assumption here is that the ball is actually thrown off from the ground rather than Mr. O's hand. Let's say I was really strong enough to throw 40 meters while I was lying down on the ground. Okay. Okay. Hopefully this helps. Hopefully you watch this. I will announce you what the homework is through the Remind app. Okay. All right. Thanks for watching. Bye, guys.